18 months ago, an OpenAI model won gold at the hardest maths contest in the world. Then, one of them cracked a problem nobody had solved since 1946. Now, they say the newest one has solved 10 problems nobody had ever solved. Each jump is bigger than the last. So how close is Astra to AGI? Or is it already there? OpenAI is now claiming that Astra just cracked 10 decade-old math problems that human researchers had basically given up on. These are structural gaps in our understanding of mathematics that the field had stopped making progress on, which means they're nothing like exam questions where you can just flip to the back of a textbook and verify the answer. Take a puzzle sitting open since 1999, where somebody asked whether a certain kind of thing could exist, and nobody could figure out how to build it. Another is apparently the first real movement on how tightly you can pack spheres together since 1978, which is the kind of conceptual leap that makes Sebastien Bubeck, OpenAI's head of math research, publicly call the AI's output beautiful. And that reaction makes total sense when you realize the sheer scale of the jump here. Because a single model spitting out 10 historic solutions at the exact same time sounds absurd. So if these are 10 answers that no human on Earth previously knew, how could anyone outside the company possibly check if they're right? OpenAI backed up their write-up by publishing every one of the 10 proofs on a public GitHub repo under an open license. The crucial detail here is that these proofs are written in Lean 4, which means they are strictly formatted code. So instead of a human having to read and subjectively agree with normal English prose, the files get fed into a compiler that acts like the ultimate automated pedant and refuses to build if a single logical step is missing. If you clone the repo and run the build yourself right now, it compiles and reports 0 gaps. And that matters because it means the AI didn't skip over any of the hard math by leaving a placeholder for you to figure out. By doing this, OpenAI handed out the one thing that lets a stranger test their claim without having to blindly trust a tech corporation, which is a level of transparency that AI labs almost never provide. But that leaves you staring at a weirder problem, because what does it mean when a computer tells you that an AI's math homework is correct? Lean is the free, open source language these proofs are written in, and it treats high-level mathematics like a compiler problem, where a proof either builds or it just fails. Unlike a human professor who might give you partial credit or let you wave your hands through a step because it feels obviously true, Lean is a rigid machine that can't be smooth-talked. If you don't explicitly spell out the mechanical logic for every single microscopic jump in reasoning, you get nothing. Now, if you get stuck and want to leave a gap in your logic on purpose, the language does allow that, but you have to type the word sorry into the code to bypass the checker. And that's why the count of those apologies is the first thing everyone checked when the files dropped, because a 0 sorry count serves as a strict binary guarantee from a compiler that every single step logically follows from the one before it. But that strict mechanical guarantee leaves one problem wide open. Because if the machine only checks that the code itself is logically sound, has a human mathematician looked at any of this? Tim Gowers answered that question back in May, which was the previous jump in this whole escalation, when the same model family decided to look at a mathematical cold case. Astra tackled a notorious geometric headache based around unit distance that had been sitting stuck since 1946, and the machine actually showed that the famous original guess was completely wrong. Usually, when a computer spits out a solution to an 80-year-old problem, you expect the experts to treat it like a frantic late-night email from a guy who thinks he just proved that 1 equals 0. But Gowers reviewed it, and 9 heavyweight mathematicians, including Noga Alon, sat down and wrote a new companion paper just to explain the AI's logic to other humans. Gowers holds the highest award in mathematics, and after reading it, he publicly stated he would have recommended the machine's proof for a top journal. That is the exact signal you want to look at here, because the people who are the most qualified on Earth to dismiss this as statistical slop took that May result seriously enough to formally build on it, and they have since pushed the math even further themselves. So if the smartest guys in the room agree the underlying logic of that previous jump was pristine, the only question left is what the electric bill looked like to find that answer. According to OpenAI, the compute cost to find these 10 proofs was roughly $2,000 in tokens. That is the part of this announcement that should probably worry you the most, because we are talking about a machine cracking a quarter century of open mathematics for less than the price of a used Honda Civic. But that number leaves something important out. That $2,000 figure only covers the successful runs that made it to the repository, and nobody has said a word about what the dead-end search attempts cost to generate. On top of that, human researchers stepped in to polish the write-ups before publication, so the machine's answers still required a person to format the final papers. Still, even when you factor in a graveyard of failed searches, the efficiency here is staggering, which leaves just one uncomfortable question hanging in the air. If the proofs are public and the tokens are this cheap, could anyone outside of OpenAI get a model to spit out the same answers? Less than a day after the announcement went live, a researcher over at Anthropic posted that he had already reproduced half of the results using Fable, a model they've already released publicly, not a secret internal build. From what people are reporting, he supposedly managed to get 5 of the 10 proofs to compile perfectly from a generic prompt, and he did it with the model's internet access switched off. That cuts two ways, because a rival lab independently hitting the exact answers in a single day is the strongest outside corroboration this claim could get. You don't have to trust OpenAI's benchmarks when their biggest competitor is accidentally doing their QA testing for them. But it also means that if a different model can knock out these historic proofs over a weekend with a plain text prompt, it puts a crack in the idea that you needed Astra to do it. So if the math checks out and anyone with a frontier model can run it, is there anything left to doubt here? Astra's code compiles perfectly, which feels like a checkmate until you realize what a machine checks. A checking system doesn't know the history of a mathematical field, and it only verifies that an answer follows from the question it was handed, and nothing else. The problem is that taking a famous open conjecture and translating it into a format you can feed to a machine is a manual job done by humans, and it is easy to get wrong. If you write down the starting conditions just a fraction weaker than the original problem, the compiler will happily hand you a flawless proof for something nobody was asking. Tech Times points out that OpenAI made a similar math announcement last October that only pretended to deliver, falling apart once reviewers looked at how the problem was set up. A passing check just proves the answer matches the question, which means everything now rests on whether those 10 questions were written honestly. So is this a real answer to the real problem, or a perfect answer to an easier one? So if you want to know how these models do when the problems are not handpicked, you need a blind test, which is exactly what a group of professors and PhD-level competitors built in a new paper called Riemann-Bench. They wrote 25 fresh research-level math problems from scratch, and they made them so nasty that each one took the author weeks to figure out. When the paper first came out, every frontier model choked, with nobody getting past 10% and the absolute best managing just 6%. But if you check the leaderboard for the middle of this year, the top scores were already in the 60s and 70s. And because that number is still moving, we don't really have a fixed ceiling yet. Which means that on problems nobody handpicked, the score went from 6% to the 70s in a matter of months, making the speed of that climb the striking part, even if they do still miss a real share of the problems. So if they are still dropping questions on a blind run, then how did another model just score full marks on a maths benchmark? To make sense of that, we have to take a quick step sideways. Because if these models are falling over on blind tests, how did another AI just score full marks on a math benchmark? Well, back in July, Mistral announced Leanstral 1.5, which is an open model that hit a 100% score on mini F2F. But the reason a perfect run there proves less than it sounds is that the benchmark is built from high school and early university competition problems. Which means the benchmarks everyone loves to quote are measuring the easy half, and a flawless score tells you nothing about a machine's ability to crack a mystery that stays open for 27 years. So bringing this back to the main thread, that leaves us holding one unanswered question. Has anyone tested Astra on real, uncurated research problems themselves? Well, yes, and it turns out the person who ran it is Terence Tao. Earlier this year, he and a few other mathematicians grabbed 10 live research problems from their own ongoing work, locked them in a sealed test, and gave the AI models available at the time a fixed window to crack them. If the official narrative holds water, you'd think a system that just cleared a 27-year backlog should easily eat a few current problems. But that's not what happened. Tao published his results, reporting that at the time of testing, the problems appeared out of reach for a single AI prompt, and that human experts had to step in to solve them instead. So the tightest, most credible independent test we have from earlier this year points in the exact opposite direction of OpenAI's perfect 10 out of 10. Which leaves us with a glaring gap, because if the models were falling flat on real-world tests just a few months ago, what are working mathematicians actually saying about those 10 proofs OpenAI just published? Well, it turns out the math itself is basically off the table, because days into this whole thing, nobody has published a hole in any of the 10 proofs. Instead, the fight has pivoted to who gets the credit. That debate got so heated that back in June, academics published the Leiden Declaration. They needed to figure out whose name goes on the paper when a computer does the heavy lifting. It is a surreal timeline where human experts are already fighting for custody of the results, while rival AI models fed the announcement cold refused to believe it. If you paste the news into a fresh chat window, other chatbots will call the results a stretch, reacting to the whole thing like it's a leaked script for a sci-fi movie. So the battle lines have shifted onto what the results mean and who owns them, since everyone seems to agree the code compiles. Which leaves one expensive elephant sitting in the room. If the math holds up, and the community is already fighting over attribution and the field's top honors, so where does all of that leave the AGI claim? Look, having 10 checked results on chosen problems and still missing a good share of the problems nobody chose are both true at the same time. Solving a chosen target and figuring out whatever gets thrown at you next measure different things. But this is the strongest verifiable evidence an AI lab has ever handed over. And while it isn't AGI, it is the first claim of its kind that can be settled. The only thing left to do is for working mathematicians to read the code and confirm those 10 written questions say what everyone thinks they say. That public reading is happening now, and anyone can follow it, which means this AI milestone is going to be proven or destroyed by peer review instead of a marketing department. Anyways, that's all, folks.